Hi, I'm Emily from emilylearning.com. In this video, I'll be going through this binomial distribution question from the 2023 H2 A-Level Paper 2. Okay, the question that we'll be going through will be question 10b on binomial distribution. It is slightly different from your usual binomial distribution question. I've provided the full work solution for question 10b, okay, as well as the other questions in this paper on my website. I'll provide a link in the description below. You'll be able to find the full work solution for question 10, okay, as well as question 10b, plus the rest of the questions in this paper here. Okay, in addition to the work solution, I also want to draw your attention to the formula list. Okay, your MF26 that you'll be using for your exam. For this question here, you will need to make use of the formulas, okay, which is from the formula booklet. Okay, one of it is the probability, finding probability, okay, using this formula for binomial distribution. Okay, and if you to take a look at this, the binomial distribution for P of x equals to x, it takes this formula. And in this formula here, there's this n choose x. So you also need to evaluate this. And this formula here, to find what is n choose x, can also be found in your formula booklet on page 2 here. Okay, so you'll be making use of these two formulas as well from your formula booklet in order to solve question 10b from the 2023 H2 A-Level Paper 2 question on binomial distribution. Now let's go through this question. So question 10b, you are told that the company also makes pens which are sold in random packed box of 100 pens. The probability of the pen being not 40 is P, where P is in between 0 to 1. For quality control purposes, a random sample of pens from each box is tested. Mr. Lu and Mrs. Ming carry out the test, but they use different methods. Mr. Lu tests a random sample of 6 pens from a box. If there are no 40 pens or only 140 pens, the box is accepted. Okay, so we know that for Mr. Lu, he tests 6 pens, right? So we can let the distribution, okay, L be a distribution, okay, or L be the number of pens out of 6 that are 40. Okay, and L will take 6, comma, so P is not 40, right? 40 is 1 minus P. Okay, so L is the number of 40 pens. Okay, so we will let L be the number of 40 pens out of 6, right? So L will take a binomial distribution with n being 6, and because I'm interested in 40, and P is the probability of it being not 40, so I have 1 minus P. Alright, okay, so in order for Mr. Lu to accept the pens, okay, in order to accept the box, right, okay, it needs to be P of L equals to 0, that means there are no 40 pens, or P of L equals to 1. So the probability that the box is accepted is equals to P of L equals to 0 plus P of L equals to 1. Okay, that is when Mr. Lu will accept the box of pen. For Mrs. Ming, he tests a random sample of 3 pens for a box. Okay, so let M, okay, be a binomial distribution, okay, for the number of 40 pens tested out of 3. So we will let M be the number of 40 pens out of 3. So so M takes binomial distribution 3, 1 minus P. So in order for Mr. Ming to accept the box of pens, okay, it must have no 40 pens in the sample that's tested. So P of M equals to 0. However, if there are 2 or 3 40 pence in her box, it is rejected. So if there's 2 or 3, it's rejected. If there is 140 pen, she takes a second random sample of 3 pens and she accepts the box if there are no 40 pens in the second sample. So it means that if M is equals to 1 in the first box, then she needs to take a second box and test it and make sure that M is equals to 0. Then she will accept it. So the probability for Mrs. Ming to accept the pens is P of M equals to 0 plus P of M equals to 1 times P of M equals to 0. Okay. Next, you're asked to show algebraically that Mrs. Ming accept a greater proportion of boxes than Mr. Lu. So you need to show that this probability here is greater than this probability. So let's do this. So P of Mr. Lu accepts box of pen will be equals to P of L equals to 0 plus P of L equals to 1. So how do I find P of L equals to 0? Well, okay, we will need to make use of these formulas here. Okay, why do I need this? Because I do not know what is R, so your GC will be unable to find it if we do not know what is R, and we also do not know what is P here. Okay, so that is why we need to use algebra, and in order to find the probability algebraically rather than numerically, we need to make use of the formulas. Okay, so I know that in order for P of L equals to 0, okay, X is 0 then, so, and I know N for the distribution of L is 6, so it's 6 choose 0 times, this P here is essentially this P here, this 1 minus P, right? So it's 1 minus P to the power of 0. 1, then here is 1 minus P, right? So, or P to the power of 6. So it's basically 6 choose 0, okay? Okay, times P to the power of 6. Okay, then plus this one here, 6 choose 1. Okay, then I have 1 minus P to the power of 1 and P to the power of 5. So 6 choose 0, 6 choose 1, you can type in the calculator. Actually, you don't need this. So 6 choose 0 is 1. Okay, have 1. So it's 1 times P to the power of 6. So here's P to the power of 6. And then here, 6 choose 1 is 6. So I have 6, 1 minus P, P to the power of 5. Okay, so this is the probability of Mr. Lu accepting a box of pen. Let me simplify it. I have P to the power of 6 minus 6P to the power of 6 plus 6P to the power of 5, which will give me 6P to the power of 5 minus 5P to the power of 6. Okay, next, let's find what is probability of Mrs. Ming accepts a box of pen. Okay, so in order for her to accept the box of pen, it is either there are 0.40 pens, so P of M equals to 0, or if there is a 40 pen, if there's just 140 pen, then the next box of the next 3 pens that he tests, okay, must have no 40 pens. Okay, next, I know that for the distribution of M, okay, N is 3. Okay, so for P of M equals to 0, it will be 3 choose 0 times 1 minus P to the power of 0, P to the power of 3. Okay, 140 pen, it will be 3 choose 1. Okay, 1 minus P to the power of 1, and then P squared. Okay, type into the calculator. 3 choose 0 is 1. Okay, so 3 choose 0 is 1. So this is also 1. Anything to the power of 0 is 1. So here's P cubed. 3 choose 1 is 3. Then I have 1 minus p times p squared. So it is p squared minus p cubed. Right? Okay. Oops. I'm not done yet. Then I'm short of this p0, right? So it's 3, choose 0, 1 minus p0, p cubed. So I still need this part. So this is for this portion here. So I still need this, which is exactly the same as this. So I just copy it again. Then I need p cubed also, because I know this is p cubed, because this part is p cubed. So here's also p cubed. So now let me simplify everything. I have p cubed plus 3p to the power of 5 minus 3p to the power of 6. All right, am I right? P3 plus P5 yes, okay, so this is what I have. Okay, so now what do I need to show? I need to show that Mrs. Ming accepts a greater proportion than Mr. Lu. Okay, so let me erase this. So you need to show that Mrs. Ming accepts a greater proportion of boxes than Mr. Lu. So how do you show it's a greater proportion? Well, you need to show that this value here is bigger than this value here, right? So for math, right, in order to show that something is greater than another, okay, there are two things to do. So if I want to say that A1 is bigger than A2, how do I show it? I can show that A1 is over A2 is greater than 1, provided, this is only provided that both A1 and A2 are positive. If A1 and A2 are positive, which I can use for this question because, okay, why? Because both are probability are definitely positive. So if I show that A1 over A2 is greater than 1, then I will show that A1 is greater than A2. And I'll use this method if it's easy to factorize and I can cancel things. Another way to show that A1 is greater than A2 is to show that A1 minus A2 is greater than 0. This method applies all the time. Okay, whether you have positive or negative number, that doesn't matter. As long as you have A1 minus A2 being a positive number, then we know that A1 is greater than A2. Okay, so let's take a look at this two here. Okay, so if I were to let me see whether we can do factorization first. All right. Okay, doesn't seem like there is much to cancel off. Maybe I can cancel a few p's off. Okay, but looking at this has p to the power of 6. This one also has p to the power of 6. This one has p to the power of 5 and so on. It might be easier for me to do a subtraction to see whether the probability that Mrs. Ming accepts a box of pen minus the probability that Mr. Lu accepts a box of pen is greater than 0. Okay, so I say again, okay, when you want to show that something is greater than another, okay, there are two ways. One way, which is the divide method, okay, if you want to show that A1 is greater than A2, you can take A1 over A2, show that it is more than 1. Then we can conclude that A1 is greater than A2, provided that A1 and A2 are both positive. Okay, that is one way of showing that two things are, to compare two things. Another method which works all the time, doesn't matter whether it is positive or negative, is when you have A1 minus A2 and you prove that it's greater than 0. Then this means that A1 is greater than A2. It doesn't matter whether it's A1 and A2 are positive or negative, one of them positive, one of them negative, doesn't matter. As long as A1 is greater than A2, A1 minus A2 will always be greater than 0. So you can show it by this method. Okay, we usually use this method if you have a lot of things to cancel, and after you cancel, you get a value like half, like 1/3, like 3, and so on. Okay, we usually use this method, okay, for all other types where it's not easy to cancel. So looking at this, right, it might be easier to cancel because I have p to the power 6 and p to the power 5 here, and here also p to the power 6, p to the power 5. So let me do some subtraction. All right, so what I'll do is I will take P, Mrs. Ming accepts box of pen minus P of Mr. Lu accepts box of pen. Okay, if I do the subtraction, okay, and then I get a positive value, it means that Mrs. Ming, the probability of Mrs. Ming accepting the box is greater than the probability of Mr. Lu accepting the box. So let's do it this way. So I have P cubed plus 3P5 minus 3P6 minus 6P5 minus 5P6. Okay, so once I'm done with this, let's simplify. So the PQ has nothing to subtract away, so I'll just keep it as PQ. Okay, so minus, I'll end up having minus 3P5 plus 2P6. Okay, so now that I'm done with this, I have P cubed minus 3P to the power 5 plus 2P to the power 6. I need to show that this is greater than 0, right? So I need to show that this is greater than 0. So what I'll do is I'll first factorize as much as I can. So I end with 1 minus 3P squared plus 2P cubed. Okay, and I'm going to factorize it. Okay, I'm going to find the factors. So this is what I get, p squared. So when I factorize this, this is what I get. Okay, and I know that p is in between 0 and 1, right? So in other words, p is a positive value. Since p is in between 0 and 1, p cubed will always be greater than 0, right? Okay, and I know that 2p plus 1 will also be greater than 0 since p is in between 0 and 1. P is a positive value, right? So you have 2 times a positive value plus 1 is definitely going to be positive. P minus 1 squared will be greater than or equals to 0 for all real values of p because all square numbers are positive. Okay. It will not be equals to 0 because p is lesser than 1. Okay. So I know that p cubed is more than 0, 2p plus 1 is more than 0, p minus 1 squared is more than 0. So when you multiply 3 positive values together, what do you get? You get a positive value, right? So we know that p cubed times 2p plus 1 times p minus 1 squared will be greater than 0. So I know that this value here is basically probability of Mrs. Ming accepts a box minus probability of Mr. Lu accepts a box. Okay, and I know that it is greater than 0. So therefore, the proportion, okay, therefore it is likely that Mrs. Ming, okay, accepts a greater proportion of box than Mr. Lu. Okay, so since we know that P of Mrs. Ming accepts a box of pen is greater than P of Mr. Lu accepts a box of pen. So we can conclude that, okay, what did they ask? Mrs. Ming accepts a greater proportion of box than Mr. Lu. So therefore, Mrs. Ming accepts a greater proportion of boxes than Mr. Lu. Alright, so that is how you do this question. To show that something is greater, you can take A minus B. To show that A is bigger than B, you take A minus B, it is more than 0. Okay. A1 is greater than A2, then you will take A1 minus A2 and show that it is greater than 0. Okay, and that is what we use for this question here.